right, this video is over solving radical equations. The first thing that you want to do is you want to isolate the radical on one side of the equation. So like on number 1, we would want to get the radical over here by itself. So to do that, we've got to move the 5 over here by subtracting it. Okay, the next step is that you want to raise each side of the equation to the power of the index to eliminate the radical sign. Well, the index on this one would be 2. It's a square root. So we're going to square each side. When you do that, the square root and the square cancel each other out, and you're left with x, and 7 squared is 49. So x equals 49. The following thing that you need to do is you always need to check to see if you have any extraneous solutions. So you do that by plugging this 49 back into the original equation right here to see if it's the same answer. The square root of 49 is 7, and 7 plus 5 is 12, so it works. So that's your answer. Okay, on number 2. So first thing you want to do is you want to subtract 3 over. So you have negative 4th root of m equals negative 3. This negative is like a negative 1, so we've got to divide both sides by negative 1. So the 4th root of m equals 3. Okay, so to cancel out the 4th root, we've got to multiply or put both sides to the power of 4. So the 4th root into the power of 4 cancels, so we're left with m equals, well, 3 to the power of 4 is 81. Okay, so then you want to plug that back in here and check to see if it's going to work. Well, the 4th root of 81 is 3, and 3 minus 3 equals 0, so that works. Okay, number 3, subtract 10 over. So you have the square root of a plus 7 equals 1. To cancel out a square root, you square both sides. So we have a plus 7 equals 1 squared is 1. To finish solving, subtract 7 over. You have a equals negative 6. Okay, so then we want to plug that back in and check to see if it works. So plug the negative 6 in, so negative 6 plus 7 is 1. The square root of 1 is 1. 10 plus 1 equals 11, so it works. Number 4, we want to subtract 10 over. 3 minus 10 is negative 7. Okay, to cancel out a square root, we want to square both sides. So you have 6w minus 5 equals negative 7 squared is a positive 49. Make sure you put that in parentheses before you square it. Okay, finish solving. So we're going to add 5 over. So you have 6w equals, well, 49 plus 5 is 54. Divide by 6, and w equals 9. Okay, let's plug it back in and check to see if it's going to work. So you have 6 times 9 is 54. 54 minus 5 is 49. The square root of 49 is 7, and 7 plus 10 is 17. So that would be 17 and 3. They do not equal each other. So since they do not work, this is going to be a no solution. Okay, number 5. Remember that to the power of 1/2 is the same thing as saying the square root of this. Okay, so if you want to put a square root right there instead, so you know that that's what it's talking about, it's the same thing. Okay, so first we have negative 9 is multiplied times this. So to start off with, you want to divide both sides by negative 9. So it gives you 4 equals the square root of c minus 12. Okay, so to cancel out a square root, you want to square both sides. So you have 16 equals c minus 12. Add 12 over. You have 28 equals c. So then you want to plug that back in and check to see if it's going to work. So you plug 28 in, so 28 minus 12 is 16. The square root of 16 is 4. Negative 9 times 4 is negative 36, so it works. Okay, number 6, same thing. So this is to the power of 1/3, it's the same thing as saying the cubed root of. Okay, so first you want to subtract 11 over. We have the cubed root of 7p minus 1 equals 7 minus 11 is negative 4. So to cancel out the cubed root, you want to cube both sides. So 7p minus 1 equals, well, negative 4 to the power of 3 is negative 64. add 1 over. We have 7p equals negative 63. Divide both sides by 7, and you get p equals negative 9. Okay, so let's plug that back in and check to see if it's going to work. So 7 times negative 9 is negative 63. Negative 63 minus 1 is negative 64. Okay, take the cubed root of negative 64, and you get negative 4. Negative 4 plus 11 is a positive 7, so it's going to work. Okay, number 7. First thing, you want to add 9 over. So the fourth root of 8k plus 12 equals negative 11 plus 9 is a negative 2. To cancel out a fourth root, you want to raise it to the power of 4. So you have 8k plus 12 equals negative 2 to the power of 4 is 16. Subtract 12 over. You have 8k equals 4. Divide both sides by 8. And you get k equals 1/2 because you want to simplify 4/8 down. Okay, now let's plug 1/2 in. So 8 times 1/2 is 4. 4 plus 12 is 16. The fourth root of 16 is 2. 2 minus 9 is going to be negative 7. So that ends up being negative 7 and negative 11. Do those equal each other? No. So since that does not work, this is going to be a no solution. Okay, number 8. So first thing you want to do is subtract the 18 over. That gives you negative 20. So you have negative 4 square root of 43 minus 3x equals negative 20. Divide both sides by negative 4. Square root of 43 minus 3x equals 5. To cancel out a square root, we're going to square both sides. 43 minus 3x equals 25. Okay, subtract 43 over. So you have negative 3x equals negative 18. Divide by negative 3. And x equals a positive 6. Okay, you want to plug it back in and check. So we have 3 times 6 is 18, so you have 43 minus 18 is 25. The square root of 25 is 5. Negative 4 times 5 is negative 20. Negative 20 plus 18 is negative 2, so it works. So x equals 6. Okay, let's flip over to the other side. All right, notice now we have radicals on both sides, okay? Well, they have the same index. So you're gonna multiply both sides, or I'm sorry, not multiply, you're going to raise both sides to the power of 2. When you do that, it just cancels out the radicals, and all you're left with is u minus 8 equals 43 minus 2u. Okay, then you wanna solve it from there. So we always wanna move the variables to the left and the constants to the right. So we wanna add 2u over, becomes 3u, add 8 the other direction, becomes 51. Okay, divide by 3, and u equals 17. Okay, you want to plug it back in and check. So 17 minus 8 is 9. On the other side, you have 2 times 17 is 34. 43 minus 34 is 9. So both sides work. So u equals 17. Okay, so on this one, same thing. They're both to the fourth root, so that means we have to raise both sides to the power of 4. That cancels out the fourth root, so we have 27 minus 2d equals d minus 3. Subtract d over. That gives you negative 3d. Subtract 27 the other way. That gives you negative 30. Divide by negative 3. And d equals a positive 10. Okay, plug it back in and check. So you have 2 times 10 is 20. 27 minus 20 is 7. So you have the fourth root of 7. On this side, you have 10 minus 3 is 7. Fourth root of 7. So they're the same on both sides. So it works. Okay, on this one. So we actually have something on the outside here that first we want to get rid of. So the easiest way to do that is divide both sides by 4, and that leaves you with the square root of 3q plus 15 equals 3 square root of q. Okay, now you still have something outside of the radical here, but that's fine. Okay, so to cancel out this radical, you want to square both sides here. So that gives you 3q plus 15. But over here, we're squaring this entire thing. So 3 squared is 9. And the square root of q raised to the power of 2, that cancels, so you're just left with a q. So you have 9q. Okay, so then we want to solve. So we're going to subtract 3q over. So you have 15 equals 6q. Divide by 6. It's not going to divide evenly, so we just want to simplify our fraction down so they both divide by 3. And so q is going to equal 5 over 2. Then you want to plug that back in here and check. And when you plug it back in, it's going to be the same on both sides. You're going to end up getting 12 square root of 5 over 2 on both sides of the equation. So it's going to work. So that's your final answer. Okay. On this one, we don't have anything outside of the radical right here, so let's just go ahead and try to cancel out as many radicals as we can. So this is the cubed root, so we want to raise it to the power of 3. So that's 14 minus 10n. On the other side, we have negative 2 to the power of 3, which is a negative 8. And the cubed root of n to the raised to the power of 3, those cancel, so you're just left with n. Okay, so we want to add 10n over. So we have 14 equals 2n. Divide both sides by 2, and n is equal to 7. Plug it back in and check, and it's going to work on both sides. So that's your answer. Okay, on 13, we have a radical on this side that we need to cancel. So it's a square root, so we want to raise it to the power of 2. So we have 8x equals x squared. Okay, anytime that you have an x squared or a variable raised to the power of 2, you always want to have to factor it, okay? Or you're gonna have to factor it to be able to solve it. So the first thing that you need to do, so we've got to move this 8x over here. And we want to move the 8x over because this x squared is already a positive. So to move the 8x, you've got to subtract it over. So this turns into x squared minus 8x equals 0. Okay, so how can we factor this? What's the greatest common factor we can take out of both of these? We can take an x out. So x squared divided by x is x, and negative 8x divided by x is negative 8. So now to solve, we just set both of the factors equal to 0 and solve. We have x equals 0. We have x minus 8 equals 0. To finish solving this, you want to add 8 over, so it turns into x equals a positive 8. So now we have to check both of these answers and see if they work. So if you plug the 0 in, okay, well 8 times 0 is 0. The square root of 0 is 0. Plug 0 in here, it's 0. So the 0 is going to work. Okay, then we plug the 8 in. So you have 8 times 8 is 64. The square root of 64 is 8, and the other side is 8. So that's going to work as well. Okay, so both answers right there are going to work. All right, on 14, we need to isolate a radical. So first we want to subtract 7a over. So you have the square root of 12 minus a equals 8a minus 7a is just a. To cancel out the radical, we've got to square both sides. So 12 minus a equals a squared. Because we have an a squared, we want to move everything over to that side. So this turns into a squared. We have to add a over. We've got to subtract 12 over. We have to factor. What multiplies to get you negative 12 and adds to get you 1? 4, negative 3. So you say a plus 4, a minus 3. Set both of them equal to 0 and solve. So we have a plus 4 equals 0, which turns into a equals negative 4. We have a minus 3 equals 0, which turns into a equals a positive 3. Then you want to plug them back in and check to see if they're going to work. So the negative 4, so we have 12 minus negative 4, which turns into 16. Okay, the square root of 16 is 4. And then right here, we have a negative 4 in there. So plus 7 times negative 4, which is a negative 28. So you had 4 and negative 28, which is a negative 24. On the other side, so we have negative 24 on the left side. On the other side, if you plug negative 4 in, it's 8 times negative 4 is negative 32. Since those do not equal each other, this answer is not going to work. Okay, now let's check the 3. So if you plug 3 in right here, it's 12 minus 3 is 9. The square root of 9 is 3. And then right here, you have 7 times 3 is 21. So that was 3 plus 21 is 24. On the other side, you have 8 times 3 is 24. So this works. So this is going to be your answer. A equals 3 is going to work. Okay, on 15. We don't have anything to move, so we just need to cancel out the radical. So we're going to square this. Okay, so this turns into 6m minus 38 equals, when you square this, you can use your reference sheet and do it, or you can write it out twice and FOIL it. Either way works. Okay, if you use the reference sheet to do it, then that's m squared is m squared. And then you have minus, you multiply these two together, so 5 times m is 5m, and then you also want to multiply that times 2, which is 10m. And then you want to square 5 squared is 25. Okay, so now we want to move everything over to the same side. So let's move we're going to subtract 6m over, and we're going to add 38 over. So this turns into m squared. Subtracting 6m over, so negative 10m and negative 6m is negative 16m. Add 38 over, so 25 plus 38 is 63. Then you want to factor. So what multiplies to give you 63 and adds to give you negative 16 is going to be negative 7 and negative 9. So you have m minus 7 and m minus 9. Okay, so then you want to set both factors equal to 0 and solve. So m minus 7 equals 0 and m minus 9 equals 0. Turns into m equals 7 and m equals 9. Okay, so then you want to plug both answers back in and check to see if they're going to work. And it looks like both answers will work. Okay, on 16, same thing. So we have to square both sides. So that turns into 2v plus 3 equals, so we want to square this. You can write it out twice and FOIL it, or you can use your reference sheet. So it's v squared, and then you multiply these two together, which is 2v, and then multiply that times 2, which is 4v, and then 2 squared is 4. Now we want to move everything to the same side. So we have v squared, subtract 2v over, so 4v minus 2v is 2v. Subtract 3 over, 4 minus 3 is 1. What multiplies to give you 1 and adds to give you 2 is 1 and 1. So we have v plus 1, v plus 1. Set them equal to 0 and solve. Since they're the same, you only have to do one of them because we get v equals negative 1. There's no point in doing it twice. Okay, plug that back in and check, and it's going to work. All right, 17. So same thing. We don't have anything we need to move, so we just want to square both sides here. So we have 51 minus 5y equals, we can either write that out twice and FOIL it, or you can use your reference sheet. So y squared minus, multiply these together, 11 times y is 11y, multiply times that times 2 is 22y, 11 squared is 121. Okay, now we want to move everything over. So we have y squared. You got to add 5y over, so it's negative 22, and 5y is negative 17y. We've got to subtract 51 over, so 121 minus 51 is 70. What multiplies to give you 70 and adds to give you negative 17 is negative 7 and 10, negative 10. So it's y minus 10, y minus 7. Set both factors equal to 0 and solve. You get y equals 10 and y equals a positive 7. Okay, then you're going to plug both of them back in and check to see if they're going to work. And actually on this one, neither answer are going to work. So this would be a no solution. Okay, 18. So we do have this negative 1 outside of the radical here. So make sure that you do pay attention to that. We need to square both sides. Okay, so this turns into x plus 9 equals, over here, we've got to do the same thing. Even though there's part under the radical and part not, we still have to do the same way we just did these last couple of ones. Okay, so square root of x raised to the power 2. Well, the square root and the power 2 cancel each other out, so you have x, then it's minus. Multiply these together, so that's 1 times the square root of x, which is just square root of x, and then that times 2, which is 2 square root of x, and then 1 squared is 1. Okay, we want to try to get everything to the same side. We really want to isolate our radical here, so we want to subtract x over. That cancels. We want to subtract 1 over. It gives us 8 equals negative 2 square root of x. We want to divide both sides by negative 2. So we have negative 4 equals the square root of x. What cancels out a radical? Well, let's square both sides. Okay, so then we have x equals negative 4 squared is 16. Okay, we want to plug that back in and check to see if it's going to work. It's not going to work. You're going to get 5 on one side and 3 on the other side. So it is not going to work, so this is going to be a no solution. Okay, all right, so this is solving radical equations. Just remember you want to isolate your radical and then raise each side to the of the equation to the power of the index to eliminate out the radical sign, then solve the remaining equation, and always check to see if you have extraneous solutions.